So let's turn back the clock a little bit to your PhD. You wrote this in the fall of 1956. This was a very turbulent time in Hungary. That was the time of the Hungarian Revolution, uprising against Soviet domination, and at the same time you had a 3-year-old child. How were you able to write your dissertation under such circumstances?
Just because life was not quite normal, and there was fights on the street and everything. Of course, the school stopped and university teaching stopped, so I had much more time. Of course, I never left home, and for a while we were in the basement, and there I had more time than ever before, and then I had time to write and to work on that problem.
So that's one instance of being able to do creative work under rather depressing circumstances, like when there is street fighting outside and you are afraid that your house can get a hit.
Yes, but I don't think that this is such a very important example for that. Much better example is what my husband Paul Turan did while he was in labor camp.
We are talking about forced labor companies in 1944.
Yes, and this was in between 38 and 44. Several times he was in labor camp.
People of all walks of life, including academics, including well-known scientists, were sent to do manual physical labor. Paul Turan was one of those mentors, my mentors, who actually did mention this to students on various occasions on graduation, and he mentioned stories about how he was able to do great mathematics under the worst of circumstances. So one of these cases involved him having to repair, electrical wires on the top of a telephone pole. And Vera, maybe you can say something about what theorem was born.
This was a Turan extremal graph theorem, which says that if you do not have a complete graph of a certain size, then you cannot have too many edges. And this is what he determined, the maximal number of edges what a graph can have.
Paul Turan's usual comment to this was that in contrast to the analytic number theory, for which he would always need paper, graph theory he could do in his head, and that gave him freedom.
And in some sense, it saved his life, because he was able to work in mathematics in that circumstances. So working in a brick factory, he realized what is a mathematical problem, what they have when they had to carry bricks.
I heard this from Paul Turan himself. He talked about this too at events, at graduation events, and it was one of his favorite examples of how good mathematics can come out of abominable circumstances. So he had to push this cart, and wherever the rails would meet, the cart would somehow, just some bricks would fall off the carts, and so it occurred to him how one could draw a graph in the plane with minimal number of intersections. So this became an important problem in graph theory.
Not only in graph theory, but in electric engineering, I think. So the problem came from real world, and it became important in designing
printed circuits.
Yes.
Boards, yes.
And the other thing, which has even a longer story, that he find his so-called extremal graph theorem in labor camp. Graph theory was not at all his subject. His subject was analytic number theory. And why he started to think on graph problems, two, was because, as we know, in analytic number theory, you really need paper and pencil. It needs a lot of writings, it is full with formulas, but not in graph theory. So in graph theory, you can think on the problems when you are forced to be on the top of a telephone pole. And this is what he did. Maybe one of the most developed class of problems or theory in graph theory is the so-called extremal theory. And extremal theory became important not only in graph theory, but in set theory, in a lot of different structures.